So now we are going to see about pointers. Okay, so pointers or variables that store the address of another variable. Okay, so pointers are variables that store the address of another variable. Okay, are you following this? Fine. Now let me explain to you with a diagram. Say for example, you have a memory. Okay, and no, let me just draw blocks of memory. Okay, let me just draw blocks of memory. Hold on. Right, fine. Now let me give some address for this blocks. Okay, say for example 1000. Okay, don't worry about this because always the address is going to be hexadecimal, but here just for our understanding I'm giving it as a 1000, okay, but usually the address will be in hexadecimal. Okay, this is just a block of memory. Okay, this is just a block of memory. I'm just having this, no, 1000. These are some of the addresses. Okay, yeah. So here this one is 1000. Okay, this one starts from here 1010. It's 1020. This is 1030. This is 1040. Just for your understanding. Okay, fine. Now let me say int a. This is the variable declaration int a. Now actually, what is happening? Now when this int a is executed, what happens? We know that this is variable declaration, right? This is variable declaration. So what does variable declaration do? First thing, it decides on the data type. Okay, so we know what is the data type, right? And because we know the data type, we know the size required for that variable, right? Correct, because say for example it's an integer. If the integer is going to occupy 4 bytes, that means your variable a requires 4 bytes. And now where is this variable going to be stored? Okay, so I have a variable called int a. A is an integer variable. That means it requires 4 bytes of memory space. Now what happens? Now it goes and checks the memory for 4 bytes. Okay, say for example, so all these are already occupied. Fine. So all these are already occupied. So now what happens here? These spaces are not free actually. Okay, these spaces are not free. And say this space is also not free. Now what happens? It goes and checks for a free memory space of 4 bytes. Assume from 1000 to 1010 it is free. Okay, so it wants only 4 bytes of memory space. So what happens? It will allocate 1000 to 1004, okay, for A, right? So it's going to allocate 1000 to 1004 for A. Okay, right? So what happens here? This is going to be 1000, from 1000 to 1004. This A variable will take the space. Fine. Now, when I say int a, what happens? Let me repeat again. A is a variable of type integer. So A requires 4 bytes of memory space because it's an integer. So it goes and checks the memory for free bytes, free 4 bytes, continuous free 4 bytes. And it just uses the available free 4 bytes for A. So what happens? This space, okay, this space, say for example, if this space going to be 1000 to 1004, okay, so this space will be identified as A. Okay, so that's why we call the variable as a identifier, because this memory space is going to be identified as A. So 1000 to 1004 bytes are going to be identified as A. So we call it as a identifier. Now, what is the address of A? Yes. So what is the address of A? So address of A is going to be 1000. Correct. Because Where is the A located? In the 1000 address space. So the address of A is going to be 1000. And what is the address of operator? Ampersand. So ampersand A will be 1000. Correct? The address of A is ampersand is address of operator. So address of A will be 1000. Now, what is the value of A? So here it depends on the A, the scope of A. If A, assume A is a local variable, now it's going to be some garbage value. What is the garbage value here? This space would have been used by some other program some time earlier. Okay, so now that file is not using this space. So some value would have been present there because of that particular program. So that value will be the value right now for A. So that's why we call it as a garbage value, because we don't know what value is present in this location. So it's a garbage value. Okay, so garbage value in the sense it's not useful for our program. Okay, I'm not going to use that value. Fine. So what is that we have understood? When I say int A is an integer variable and it occupies 4 bytes of memory space. So it goes and checks for free 4 bytes in the memory and it just allocates A to that free 4 bytes. So now this space will be identified as A. Now what is the address of A? 1000, because from 1000 to 1004 A is located. So address of A is 1000. So address, you use address of operator. And what is the value present in A? If A is a local variable, there will be some garbage value present there. That will be the value of A. So A has some garbage value. Fine, is that clear? This is what this int A statement does. Okay, so int A does so many things here. When a variable is declared, all these things happen in the memory location. Okay, fine. Now, what will I do here is, just a minute. So let me erase the entire thing. Okay, now let me take the same memory space and try to do with pointers. Okay, so let me draw the memory again. Okay, so this is just a simulated memory. Please don't take this as a real one, because the real one always address will be in hexadecimal. Okay, and so on. Okay, let me not complete all the remaining things. Now let me assume that these spaces are filled. Okay, these spaces are filled. Okay, fine. Now let me write a statement called int star p. Okay, so now we are going to talk about pointers. Okay, so you should understand we are going to talk about pointers. Okay, so what are pointers? Pointers are variables that hold the address of another variable. Okay, so when you see that, pointers are going to hold the address of another variable, right? So what do you mean by that? Any pointer for that matter is just going to hold the address of another variable. Now what is the data type of a pointer? It's void store, right? Because it's going to hold the address. It's going to hold the address. So it's not going to be an integer, it's not going to be a float, character, whatever it is. So pointers are going to hold the address of another variable. Okay, now when I say int star p, what is this? I have declared p variable as a pointer variable. That's how I declare. Okay. So int star p. So the star p says p is a pointer variable. You can also declare a pointer variable using star space p. Okay. Or you can also say, there is also other way of declaring. The other way is int star p. Okay, you can put a space before, after, and all those things. Now, what is this statement doing? P is a pointer variable which is going to hold the address of integer variable, right? So what is this we are doing here? P is a pointer variable. The star says it's a pointer variable which is going to hold the address of integer variable. Fine. Okay. Now let me remove this. These are the different ways of declaring. Now let me have another variable called a equal to 10. Now I'll just include a statement here, p equal to ampersand a. Okay. So what is this doing? Okay, let us see this. Say int star p. So p is a pointer variable. Fine. Now p is not pointing to any address. Now I've just declared p is going to hold the address of an integer variable. Fine. Let me assume I'm going to have p here. Right? Fine. So p is going to, right now it's not holding any address because I've not given anything. I've just said p is a pointer variable which is going to hold the address of an integer variable. Fine. What does the next statement do? Int a equal to 10. As we saw earlier, again it finds 4 bytes of free memory space, allocates that space to a and assigns a value of 10 to it. Correct? That's what this statement does. Now, what is this statement doing? P equal to ampersand a. So what is this p equal to ampersand a going to do? Right. I am assigning the address of a to p. We know that p is a pointer which is going to hold the address of an integer variable. So when I say p equal to ampersand a, ampersand is nothing but address of operator. So I am finding the address of a and assigning it to p. What is the address of a? 1030. That's the address of a. Now what is p? P will hold the address of a. So p will be 1030. Is that clear? So p equal to ampersand a. So p is a pointer variable which is going to hold the address of an integer variable. So a is an integer variable, correct? So I'm assigning the address of a to p. So address of a is 1030. So my p will be 1030. Is that clear? So with this, I hope it's clear. So with this, we'll stop the pointers and I'll continue this in the next video. Thank you.